Hello, I welcome you all to this another interesting screencast where we're going to be solving this engineering mechanics problem. And it reads, determine the force in the members J, E, and GF of the truss and state if these members are in tension or compression. Also indicate all the zero force members. Right, so let's start with the zero force members. Zero force members, these are members with no force in them. There is zero force in them. All right, so we are going to use two principles for this particular case. So let's look at joint D. Joint D is a truss joint that is created by two non-collinear members. Okay, two non-collinear members. These members are CD and DE. So basically they are saying, we are saying these two members are not in a straight line. All right, they are not in a straight line like so. They are non-collinear. All right, they are non-collinear. They are not in a straight line. Okay, so because they are not in a straight line, and then because they do not meet condition one, I'll call this. So the first condition, they are non-collinear. The second condition has two properties, if I would call them. One, there is no applied load at D. Okay, no applied load, no load, applied load. Two, there is no support reaction. Okay, and three, either no load, both no load plus support. Any of these, any one of these. If there was load at D, then of course these members could not have been zero force members. If there was a support reaction at D, then these two members could not have been zero force members. If we had both load and no support, okay, so we have no support. If we had load and support reaction at D, then we could, so we have three of these, either of these: no load, no support reaction, no load, and no support reaction. Okay, so we don't have them at D. And when you look at D, D is similar to B. So because these conditions are met, they are non-collinear. One, two, there is no load, or there is no support reaction, or there is no load plus no support reaction. All right, none of these conditions are met. All right, and because of that, then they qualify to be classified as zero force members. You can even do the joint, do the equilibrium equations at D and B, you'll still find the same answer, right? So we have CD is equal to DE is equal to CB is equal to BA is equal to 0 kilonewtons. Which other one? Let's look at another joint. Joint H. Okay, joint H is a truss joint that is created by three truss members. Okay, but two members AH and HG are collinear. They are in a straight line. All right. So if we have members like this that are in straight line, and then the third member that is connected to that particular joint is classified as zero force member as long as one, no load at that joint, or two, no support reaction, okay, or three, no load plus no support reaction. So any of these conditions, right? So you don't have any load, you don't have support reaction, you don't have load and support. Okay, so if we had a load here, this could not have been zero force members. If we had a support reaction, they could not have been zero force members. If we had a load and support reaction, they could not have been also zero force members. But because they don't have either of these, and two collinear, and the third member becomes the zero force member. Therefore, which one is the zero force member here? The zero force member becomes HI. All right. This is equal to 0 kilonewton. So we have 1, 2, 3, 4, 5. 5 of them. Okay, these are the ones that we can remove. We can identify quickly just by visual inspection. Right, and then the rest, I suspect they should be all loaded. Okay, unless we check by calculation. But most likely all of them are loaded except CD, DE, CB, BA, and HI. Right. So now we want to find the force in member JE and member GF. All right, so for this one, we're going to use joint E and joint F. So we need to find support reactions quickly. So let's draw a free body diagram. We have AY, we have AX, and then we have EY. All right. So summation of moments about A equal to 0, anti-clockwise being our reference. What do we have? Okay, let me just, can I move this a little bit? Okay, I move it. Oh no, okay. I'll rewrite them. Let me just move them there like so. So this one we say this HI, right? It's like this. And then this one we say these are CD, right? Like so. Great. So summation of moments about point A. What do we have? So in this particular case, assume this member is 0. This is not there. This is not there. These are all zero force members. Okay, the ones I'm cancelling out. Okay, they're all zero force members. So what has remained is what we are seeing right now. So what we have right now is just this. If I use green, what we have right now is just this, like so, like so, like so, like so, like so, like so. Okay, that is the only one that we have right now. So let's go. We have a negative moment from 6, that's 6 by 3. Then we have another negative moment, that's 6 by 4.5. And then we have positive EY by 6. Then this is equal to 0. Therefore, our EY is going to be equal to, let's grab the calculator, minus 6 by 3 minus 6 by 4.5, then divided by 6. This gives us a 7.5 kilonewtons. Okay, then we have summation of forces in the X. We already know what this result is. Ix is going to be equal to 0. Then summation of forces in the Y equal to 0. Okay, what do we have? We have AY minus 6 plus EY is equal to 0, right? But we've already found what EY is. This one here, we've already found this. Okay, so there we go. Therefore, our AY is going to be equal to, so minus 6 that's 12, then plus 7.5. How come? What am I getting? Plus 7.5. Then we have a 4.5. Okay, kilonewtons. Alright, so there we go. We have E equal to 7.5. Okay, and then we have AY equal to 4.5, then we have AX just equal to 0. Right, so now let's start doing our start working out the problem. So what we have right now is we need to go to joint E. So what do we have at joint E? We have EY, which is 7.5. Then the top chord, okay, the bottom chord AHGFE is a bottom chord, so expect it to bend like this. Sorry, expect to bend something like this, right? To bend something, I'm just exaggerating. All right, so expect, yeah, so to bend down. Therefore, this bottom chord is going to undergo tension, while the top chord, which is AICJE, is a top chord, is going to be in compression. All right. So let's say EJ is in compression, like so. This is EJ, okay, or JE. We write it the way they have phrased it in the question. Then we have this slope here, and the slope is 1.5 run and 2 rise. So we have 1.5 plus 2 rise. Root of that, that's 2.5. Okay, and then let's assume the bottom chord, this one is in tension, like we said, it's in tension. So this one is EF. All right. So now we are going to have components from this. We'll have one component like this, and this one is JE by the rise divided by the hypotenuse, which is 2.5. Then we will have another one like this. This one is JE by the run divided by the hypotenuse. Right. So let's apply the equations of equilibrium. Summation of forces in the y equal to 0. What do we have? We have 7.5 minus JE by 2 divided by 2.5 equal to 0. Therefore, JE is going to be equal to, JE will be equal to, that's 7.5 divided by 2 divided by 2.5. All right, so we have a 9.375. Okay, so, and we had assumed JE to be in compression, and so it is. Right, so then let's find the other one. Summation of forces in the x direction equal to 0. What do we have? We have JE by 1.5 divided by 2.5, and then minus EF equal to 0. All right, we've already calculated what JE is, so there we go. We just need to replace it and then calculate what EF is. So what is our EF? We need EF to find GF. Okay, so there we go. 9.375 times 1.5 divided by 2.5, we have a 5.625 kilonewtons, and this one is in tension. So once we have this, then we can consider another joint, which we're just going to call joint F. So there we go. We'll draw it here like this. So joint F, what do we have? Joint F. Joint F, we have a force, applied force of 6 kilonewtons. And then we have EF is in tension, and we found it as 5.625. And then this other force that we are calling GF is unknown, and then there is another unknown going up that we are going to call Fj. Okay, so now let's find this one quickly. Let me just do something like this. Yeah, great. So now let's apply, we need to just apply one equation of equilibrium, which is in the horizontal. So summation of forces in the x direction equal to 0. Okay, what do we have? We have minus GF plus 5.625 equal to 0. Therefore, our GF is going to be equal to 5.625 kilonewtons, and this one is in tension. Okay, I guess we are done. Let's just now try to just label our solutions. Okay, we mark them. So we have the first one, which is this one here, JE. And then we have another one there, which is GF. Alright, I guess we are done, and I hope the video was helpful. And then we have the zero force members there that we started with. Okay, so I hope the video was helpful. If it was, give me a thumbs up, like my video, share my video, and continue subscribing. Thank you for your support. Bye bye, and see you in my next screencast.